Hello friends, I welcome you to my YouTube channel MakePM. So in this video we will discuss about thermal stresses. So what is the thermal stress? Suppose this is a steel bar of length L, and if we heat it, we provide it temperature delta T, we increase its temperature by delta T, then its length will increase, because we already know that if we heat something then length increases, and if we cool something then it will contract or length will decrease. So how much will be an increase in the length? So this delta L, which is increase in length, is proportional to change in temperature delta T into, and it is also proportional to initial length of the bar or rod. Now if we put delta L is equal to alpha delta T into L, so this is the length change in the length or increase in the length if we heat it by delta T. If we cool it by delta T, then it will be reduction in temperature. So what is this alpha? Alpha is coefficient of thermal expansion. Okay, if we let it expand, then its length will increase by alpha into delta into L. If this bar is fixed at the two ends, then it cannot expand. So if it cannot expand, then it will develop thermal stresses, which will be equal to applied reaction from the two ends. So let's see a numerical problem. They are based on this concept. A steel rail is 12 meter long. So given that L is 12 meter, length of the steel rail is 12 meter, and laid at a temperature of 18 degrees Celsius. So initial temperature T1 is 18 degrees Celsius. Maximum temperature is expected 40 degrees. So T final or T2 is 40 degrees Celsius. So we have to consider the maximum and minimum temperature. Estimate the minimum gap between the two rails to be left so that the temperature stresses do not develop. Okay. Here value of Young's modulus of elasticity is 2 into 10 to the power 5, and alpha is 12 into 10 to the power minus 6. So what is the temperature difference? Delta T is 40 minus 18 is equal to 12 degrees Celsius. Okay, so what will be the delta L? Increase in length is equal to alpha into L into delta, which will be equal to, so alpha is given as 12 into 10 to the power minus 6 into L is 12 meter. If we calculate in centimeter, then we will then we will multiply by 1000, because 1 meter is 1000 mm, and delta T is 12 degrees Celsius. So if you calculate this value, then you will get 3.168 mm. So one rail will expand by 3.168 mm. So we have to provide gap of 3.168 mm, so that if rail expands, then it will not cause stress between the two rails. Okay. Now we will see the second plot. Calculate the thermal stresses developed if rails if first condition no expansion joint is provided. So no expansion joint is provided means expansion is not allowed, means two rails are face to face, so it will try to expand but it cannot, so it will develop stresses. So what is the value of delta L? 3.168 mm. So we also know that delta L is PL upon AE, because from Hooke's law E is equal to Young's modulus of elasticity is ratio of stress upon strain, where stress is load upon area and strain is delta L by L. So from here you can find delta L is equal to PL upon AE. So 3.168 is equal to PL upon AE. So this P upon A is stress. So 3.168 is equal to stress into L by E. So stress is equal to 3.168 mm into E is 2 into 10 to the power 5 upon L is 12 into 1000. We have put all the values in mm. So it will be equal to 52.8 Newton per mm square. So this will be the stress if there is no expansion. Second condition is if 1.5 mm gap is provided. This is condition A, this is condition B. If gap is provided 1.5 mm, then total expansion was 3.168. Now for 1.5 mm there will be no stress, so we will reduce it. So we will get 1.668 mm. So just put this value instead of this 3.168. So sigma will be 1.668 into 2 into 10 to the power 5 divided by 12,000. So you will get value which is equal to 27.8 Newton per mm square. So this is the second case. Third condition, if stress developed is 20 Newton per mm square, what is the gap provided between the rails? So we have been given stress already. So sigma is given. Sigma is 20 is equal to, we don't know what is the gap, so delta L. Suppose gap is only delta into stress is E is 2 into 10 to the power 5 and L is 12,000. So from here we will get delta is 1.2 mm. So initial gap was, total expansion was 3.168 and 1.2 is allowed. Gap minus 1.2, if we will reduce, then 1.968 mm gap is required. So I hope you understood all the parts. If you have any doubt, then please ask in the comment section. Thanks for watching this video.